Hi there, and welcome to this first video in the yt-napari tutorial series. Today we'll be going over a brief introduction to Napari for YT users. So today we're going to cover some Napari basics. We're not actually going to use yt-napari. Instead, we're going to walk through a Napari installation and an overview of the graphical user interface, and then walk through how to manually load data from YT into Napari, and then touch on a bit of how to interact with that data once it's in there. So today, what you'll need is a Python virtual environment manager. It doesn't matter too much which one you use. Conda, virtual, and Env will both work. It's also a bit easier to do this starting from a fresh Python environment, and I'd recommend you use Python 3.9 or greater. And before we go in, I'd just like to acknowledge the Chan Zuckerberg initiative for a couple of grants that made this work possible. Both the original development of the yt-napari plugin, as well as this tutorial series, and some further development have benefited from a couple of grants. So thanks to CZI. Okay, let's get going. Okay, great. So here I am in a terminal. So I'm going to start out by creating an actual fresh virtual environment. So I use virtual env or pyenv virtual env. So I'm going to create a environment with Python 3.10.11. I'm going to call it yt-napari tutorials. Give that a second to get going. If you were using Conda, you would just do a Conda create -n, give it a name, and you can specify a Python version if you want, but we're going to keep going with pyenv. So let's activate that environment, and we're going to install a couple of things. So first, let's just upgrade our pip just in case. And so first off, actual installation, we're going to install Napari, and we're going to do a pip install Napari with this all in brackets, and what that all does is it just tells the Napari installation procedure that you want to install the default Qt backend, which is pyqt5. If you have a reason for wanting to change which Qt backend is used, you can check out napari.org for how to select a different backend. And once that's done, the one other package we're going to install is yt. If you were doing this from an environment where you already had yt, you might be able to skip this step. And if not, you'll want to for this demonstration, I'm going to do a full yt install with all of the optional dependencies. Here we go, pip install yt full. And the full install here will give us just a few extra libraries like h5py and pooch, so that we can use some of the new yt helper functions for loading sample files easily. And we'll just wait for that to finish. Okay. Oh, one more install. We do need Jupyter Lab as well. Let's do that. Okay, now we are ready to actually start up Napari, so let's do that. just type Napari at the command line, hit enter, and we get our Napari GUI. So first off, let's just load some sample data, and then we'll kind of walk through what we're looking at. So hit File, Open Sample, Napari, cells 3D plus 2ch. So this will go and actually download this sample data set if you don't have it already, and it will load it in. And so you get this nice image over in the viewer window here. Bottom left we have our layer list. So this data set contains 2 channels that get loaded in as 2 separate image layers. You can toggle them individually with the little eyeball button. And this data set is a 3D image, and the default view when you load in the 3D image is a 2D slice through that image. And down underneath the imager, the slider here will control what depth you are slicing at, so you can slide through your image by moving that slider. If you want to change which axis of the image array you're slicing through, there's this button down here they can hit that will change the order that you're slicing. So if you hit that, it'll reorient the image and you can slice through in the other direction. So let's talk a bit about these layer controls here. So there's a number of controls that affect the final composite image you get out. Each of these layers is controlled separately. So as you click in it, you'll see the color map changes between the 2. And then the final image you get out depends on all of these settings. So the blending one is pretty important. This controls how the 2 separate image layers are combined. So right now the top layer is set to additive, the bottom is set to translucent. And so what this will do is it'll take this base layer image, and then the upper layer, the nuclei layer, will just get added on. The RGBA values of each pixel will get added on to the lower layer below it. And so if we change from additive to opaque, you'll see that we only see the nuclei here, just because the nuclei layer is on top. And if we instead change it to translucent, initially we see the same thing, but now we can actually change that opacity. So the opacity, as you drop it, you'll start to see the underlying image come out. If we move the membrane layer to the top, we'll just get the membrane layer because the opacity of that layer is still 1, so we can drop that again. Let's move our membrane back below though. And the minimum option here will take the minimum between the 2 layers, but you see we get nothing because both of these color maps have black as one of the endpoints of their color map, so you just end up with a black image out at the other end. Great, so that's kind of the overview of the blending and opacity here. So the contrast limits controls the endpoints of the color maps. So this is, if you're coming from YT or Matplotlib, this is equivalent to a CLIM or ZLIM attribute that you might set for a plot or color scale. And so you can slide either end of the color map, or you can right click on the bar here and get out a larger slider with the actual numerical values of your field that define the endpoints of the color map. And you can click on those and edit them manually if you want, and immediately get an update, and then hit reset to get back to what it was. Cool. So that's a quick overview of the 2D view, but let's now switch over to our 3D view. So down below here, there's this little cube icon or square icon, toggle ND display. Hit that and it'll drop us into a 3D volume rendering of our data. So this is very similar to how YT does volume rendering, where it'll cast rays through your 3D volume and sample along each ray. It will do that separately for the 2 fields, and then composite the final image depending on the blending. So this blending behaves in the same way as in the 2D view after those rays are actually cast through the volume. So depending on what you have set here, you can end up with some slightly funny results. So just be aware that you can change those to change how your two renderings actually get composited together. Right, so when you initially load up or toggle this ND display into the volume rendering, typically you'll get out a maximum intensity projection for the layers. So this rendering option down here, MIP, stands for maximum intensity projection. And so that's just pulling the maximum value of the sampled field along each ray path. And then some of the other options here, minimum intensity projection. If you hit that, you'll see the green layer disappears because, again, our color map we're using here, black is one of the ends, and so you end up with an empty view for that. If we switch to something else where the endpoint is not black, you'll see you get a vastly different result because the minimum value actually gets mapped to a visible color. So let's go back to green. The average along the ray path, we'll just take the average, and as you rotate it, you can kind of see that change as the nuclei alignment changes, so that the rays happen to sample values that are larger along the path, so you end up with different views. And the additive simply sums along each ray path, which is not super useful for this data set because you just end up with a uniform block, but useful to be aware of. And then finally, there's this ISO layer. So this is finding an isosurface, and you can control that isosurface value with the slider here. And so let's see if we can actually get the edges of those nuclei to show up nicely. Cool. So those are the rendering options. Unlike YT, you have these preset options to choose from, so you can't supply any custom transfer functions. So if that's something you need to do for your data sets, right now you'll have to stick with vanilla YT, or you could try using YT-IDV, which if you want an interactive option, which we're working on a bit to add some custom transfer functions to. But even just having these preset options like the maximum intensity projection in particular is super useful to have in an interactive environment for most YT data sets. Cool. So okay, one final point. I kind of touched on this earlier, but remember that even in this 3D rendering view, the layer order still matters here. So if we switch to the membrane being on top, you'll see that you just see the membranes at, so except for kind of the edge along here. And so that is because these layers are rendered separately and then composited according to this blending. So if we have this on top and the opacity is set to 1, all you see is the membranes, and then you can adjust that opacity of that top layer to change the final composite. Cool. So that's kind of the brief overview of the Napari GUI. Next up, we'll actually load in some data from YT, and we're going to do this manually in this tutorial. But the next video in the tutorial series will actually cover using yt-napari to do that. So let's close up Napari, and we're going to start up Jupyter Lab and switch to a notebook. Okay, so here we are in Jupyter Lab. Let me just move that window over a little bit. Let's open up a new notebook, and I will try zooming in as best I can so that this is visible. Cool. Okay, so what we're going to do now is load in some data manually into yt-napari using the Jupyter Notebook interface. So let's first import all the things that we're going to need. We're going to need some yt, we're going to need a little bit of numpy, and then we're going to need napari. Let's import all those. And let's start by loading in a sample data set from yt. Load sample, isolated galaxy, good old isolated galaxy. And just to remind you what this looks like, let's do a slice plot in yt of the density field. And there we are. We get out our classic isolated galaxy view. Right, so let's say we want to actually load this field, this density field, over into Napari. How do we go about doing that? So first off, we need our Napari viewer. So let's create a viewer. And that'll spawn this Napari viewer that's linked to the notebook. And let's go back to the notebook. Let's close that. Great. So in general, how you would add to this notebook, so there's, how you would add to the Napari viewer, there's an add image functionality, which accepts a data argument, which is a 3D NumPy array, more or less, or other sorts of arrays work as well, as we'll see. And then most of these other settings are simply the default settings for all of those layer controls that we talked about, the contrast limits, color map, and some of the other sorts of settings like the blending and opacity values down here, and then there's a bunch of options for transforming the layer that you're adding, which we will talk a little bit about here. But so in order for us to actually load in data manually from yt into Napari, we have to get our data in as a 3D array. And so in order to do that, there's a number of ways to do that in yt, but one of the easiest ways is to just pull out a region from your data set. So if you do it ds.r, and we're going to pull out a region that's close to the center of the domain. So we'll do a 300 by 300 by 300 array, all within 0.48 to 0.52 units, code length units of the center of the domain. And let's extract our density field. So density region gas density right, and so we have our 300 by 300 by 300 density array here, and then to add it into the viewer, we're going to use this add image function. So if you just went and added the image like this, added the data, it would load up an image, but because our density dynamic range is quite large here and very small, if you just go and load that in, it'll by default use a linear color width scale or within Napari. And so in order to actually get out something that is more useful, we're going to actually take the log of that as we add it in. So you hit add image. We'll also go ahead and right away add a second layer here. So let's extract a temperature. And go ahead and add that to the viewer. Again, we'll take the log. And this time we'll also give our new layer a name. And now when we go over to our Napari viewer, you'll see that we have our two layers. We have a temperature on top. Down below we have density. we'll double click that to change the layer name to track it a bit better. Right, so we're in our 2D view here, and so, oops, density. And let's start messing with our color maps and blending a little bit to get a nice composite image in 2D before we switch to our 3D view. So first off, up top is our temperature set to translucent, but our opacity is 1. So all you see right now is the temperature field. Unclick, you'll see density. And actually, let's rotate the axis that we're slicing through so that we get our nice view of the plane of the galaxy here. Cool. And then, okay, let's start messing with our color maps. So let's set our blending and additive first. So this will add the pixel values for each, create a composite of the two. And then we're gonna try to select some color maps that don't overlap too much so that we can see the two fields pretty distinctly. Okay, let's try a yellow for the temperature. And density. Let's start off with a red here. So yeah, you can actually see right away that the temperature, high temperature points really pop out within the plane of the galaxy here. And then let's also adjust our contrast limits a little bit here, just to really get that a little bit better defined here. And remember, you can right click the contrast limits here and set your values explicitly. And remember, because we took our base 10 log of this is the base 10 log of our field. So you want to set this in log. You want to set the exponent here, not the actual value of the field itself. Temperature, let's bump that up as well. Cool, so that's a pretty nice image of the two fields. And now when you switch to our 3D rendering, oops, that was the wrong button. Oh, it was in 3D already. I didn't realize that. We were just looking at it along a plane. So, so now you can just click and drag, and you can see our galaxy rotate here. And if you bring it along perpendicular to the plane of the galaxy, you can actually see, you know, the regions where the high temperature end of the field extends out beyond the plane of the galaxy here. Cool. So that's kind of like the overview of how you get in two regions from a YT dataset into Napari manually. Oh, one final point before I move on is that remember that these blending choices here still matter like they did in 2D, because each of the layers will be the rendering will be generated separately and then blended according to the blending and opacity that you have set. So if you remember that, if you you know, change the blending option or change the ordering of your layers, you can end up with different composite images. Cool. Okay, so so there's one more important thing to remember when working with YT data in Napari. So Napari is, you know, at its core a 3D image viewer, and it works in pixel coordinates. And so what that means is that, or one consequence of that, is if you choose a different region that you want to add as a layer, and we will make a selection that covers the same physical distance but just at a lower resolution. So our image cube here will be 50 by 50 by 50 after the selection happens. And if we just naively go and add that to our image, we'll add the temperature field, temperature give it a name. So it gets added, no problem. But you'll see up here in top left, we have a little mini low-res new galaxy. And you'll see if we switch this down to back to 2D, you don't actually see it initially because we are cutting through the center of the higher res domain, which goes from pixel coordinates from 0 to 300. But since our cube is only 50, you have to slice all the way back down to the 0 to 50 range to actually see the cross section. And so in order to fix that, what you can do is use some of these other arguments in the add image. So the translation, you can use the translation and scale to scale the dimensions of your image array to match that of what we already have. So, for example, if we wanted to actually do it in this case, if we just scale it by the factor of 300 divided by 50, so 6 here. Oops. Let's actually see what I did wrong here. That has to be a 1D array. That adds in, so that will scale our image by the factor of 300 or 50 or 6. And then when we go over, oh, that's interesting. We have only scaled one of the dimensions. So maybe, there we go. So we need to scale all of them. Let's get rid of these other ones. And add a scale for the final. Okay. So you need to scale each of those dimensions separately to the same coordinates, pixel coordinates, as the layers that you initially added. And so now you see that the low res and the high res do line up, and it's just more pixelated because it is a low resolution image. But if you wanted to, load in a low res for a certain background and then highlight a region with a higher resolution, you would have to, keep track of the pixel coordinates pretty carefully and just set these scale and translation arguments correctly. So that's one of the things that yt-napari takes care of for you pretty nicely. So that's one of the main reasons to be using yt-napari instead of doing all this manual selection. But yeah, so that is about all I wanted to cover today. Cool. So just to remind you what we've done here, and I'll leave you with a nicer image than that low-res image. So we went over just installation of Napari. We walked through all of the different features of the Napari viewer, the layer controls, the layer list, the main viewer, how to switch from 2D to 3D, some of the different layer settings individually, how the layers get blended together. And then we walked through how to manually load in data from Napari using the fixed resolution buffers by using the ds.r operator. And the next tutorial will actually get into using yt-napari to simplify some of these steps. So thanks for watching, and stay tuned.